Hello friends, my name is Kanaiya Kariya and this is the presentation for Big Data Term project. We are a group of three, myself, Atul and Pranav. So I'm going to deal with the part one of this presentation, that is data ingestion. So let's get started with that. Now topics I'm going to cover in this particular presentation is how will the data be brought into the system, means how we are downloading the data into the Hadoop cluster. And second thing is what kind of filtering is required to our data, means there will be many fields, so we need to filter the data. Third one is what kind of partition is required, which in which we are going to deal with vertical partitioning. And fourth one is what kind of serialization is required to our data set and how we are going to deal with it. Okay, so move on to the first point, but before that I'd like to explain some things about our data. Means what is the source of it, what is the format of it. So I will not take much time of that. So it's a Wikipedia database. It's from a complete from of all Wikimedia wikis, and the format of this file is XML file. Uh, the to complete data set is of 250 GB for our data set which we are dealing with. And it is separated month wise. Means for one particular month we have one separate file of XML. So I downloaded the data for 5 months. One particular month is around 50 GB, so the total data comes around 250 GB. If you see the format of data, we have around 16 to 17 fields which are embedded with the inside the page and slash page. So this is the main data which we are looking for. And if you see, there are few fields which we are trying to extract, that is title, you can see ID, then revision of that particular page, timestamp when it is revised, who is the contributor that for that particular page, like username and unique ID for that particular username, and few other fields are there which are not very important to us. So while parsing and taking the filtering data, we'll ignore those fields. And one more important field for us for our query is this bytes field. Yeah. This byte field is telling about how much bytes is uh, used by this particular Wikipedia server for this particular operation or page for this particular revision. So coming on to the next slide. So these records will be many records in our one XML file for one particular month. So we'll parse this data. Now the very first point, downloading the data. So we have downloaded the data to our local directory first, which is available on chip cloud 1. So 1 month of data is around 11 GB when it is compressed. So when we download data, it was in compressed format. So we downloaded 5 files for 5 months using the wget command. And once downloaded, to unzip it, we use the bzip command, bzip2 command, because it was zipped with bzip2. So after unzipping the 5 files, one file is of around 50 GB, and we have downloaded it to folder project raw data, which is our local directory. And after extracting, you can see this. These are the file contents. So 5 files. So that was quite easy job till now. Coming on to the next thing, filtering the data. As you saw that there are many fields which are not very useful to us or for our query. So what we are going to do is we'll be filtering our data. As of now, I have created one Java code. I was trying to filter the means parse the file and filter the elements using Java code. So for now, I was able to pass the file. You can see the output below. This from the Java console, and I was able to extract all the information from that particular XML format. Still, we are trying to get some other some other code for this, so that we can directly do maybe in Python or some other code. So as of now, we have this, and we are trying to convert this into CSV format to store it in our Hadoop cluster, which will be considered as our master data set. From this also, I'll filter a few fields which are not required, but just to pass the file, I'm showing all the data which is there in that. So this is just the trial version for this, but it is working fine. Yeah. The next thing is data partition. When we downloaded the files, we downloaded month-wise because each file, if in downloadable links, it was month-wise. So when we downloaded the data, we downloaded 5 files for 5 different months. So by default, those particular files are sorted month-wise. So what we are going to do is we are going to save that partition scheme, and will be using the same thing. Month-wise, we'll be storing the data, which will be easy for us to pass the file month-wise. If we need any record for that particular month or for date range, so it will be easy just to go and check that particular file. So we'll preserve that. As you can see, I tried to see the information of the files I had downloaded. Here below is the screenshot for the same, just to give the information about how it is. So you can see all single file is around 50 GB, and data I told you it's month wise: September, October, November, December, Jan. And this is the name of file. Here also this name only indicates what that thing, month, and these are the axes. So it's fine till now. Moving on to the next slide. Next topic, that is data serialization. So as we know, our input data is an XML file, and we are using Java for that particular XML file parsing. So in Java code also I can do the enforceable schema and store it according to that. But as I told you, I'm looking for some other code also. So we are using this serialization and deserialization by IBM SPSS. Still, we are not sure whether we are going with this or not. But as of now, yes, this is the one thing which we have. Now you can see that this is I have selected few fields: ID, title, contributor, just to show in this code. And the format of that particular will be from this particular serialization and deserialization. You can see spss.hive serialization xml serde, and I'm pulling it from the records and I'm storing it in that particular attributes: id, title, and this is the path in xml file. As you can see, I showed in previous also. So this is a path in xml file. So I'm trying to extract this and store it in this attribute. Store it in this variable. And I have given few more specification like input format and output format. Input format is specified this again with this IBM SPSS format, and output format is Hive format, as I'm going to create the table in Hive. So this, and my data starts from page and ends with slash page. So this is how I'm going to extract the data for from the input file. So if it starts with page, it will extract all the information and it will end at slash page. Again, for row number 2, it will go on extracting whatever the means till the bottom of the file. So that should be, I think that should be enough for our thing for now to query to run. Still, we'll try to figure out what can be best for us so that query can be flawless. We'll be able to run it as required. So basically, I just want to say that we have one more video for this where we are going to deal with queries of this, and it is explained a lot better how queries is going to implement. So I request you do watch our second video, which will be presented by our other group member. And if you have any questions, you can contact me. My name is Kanaiya Kariya, email ID kriyink at cmich.edu. Thank you.